Okay, so now I will discuss if I consider a subspace of a finite dimensional vector space having dimension of the subspace is k and the dimension of space is suppose n, then we will show that the subspace of dimension k is basically intersection of n minus k hyperspace. I mean it is like this, is a consequence of my previous results. If W is the k dimensional space of n dimensional vector space, then W is the intersection of n minus k hyperspace in V. I will prove first through the examples and then theoretically also I will prove it. So, I have taken a subspace W of R5 space, I mean space of 5 tuples. So, the dimension of the V equal to R5 is equal to 5 and the subspace W, which is basically spanned by the given 4 vectors say alpha 1, alpha 2, alpha 3, alpha 4, I do not know dimension of the subspace W. The dimension of the subspace is maybe 4, maybe 3, maybe 2 or maybe 1. If it is say 4, then I have to prove that this subspace is intersection of 5 minus 4 hyperspace, I mean 1 hyperspace. If it is 3, then I have to prove that it is basically intersection of 2 hyperspace. Means that there exist 2 linear functionals on R5 which are linearly independent to each others, then linearly independent, and these 2 linear functionals will annihilate this subspace W. That is the meaning of the above corollary also. So, W be the subspace of R5 spanned by this alpha 1, alpha 2, alpha 3. Find required hyperspaces which annihilates net W. The question please. So, let me go to the solution please. First I have to identify what is the dimension of the subspace W. So, first we have to find the dimension of W. So, for this I will take the help of elementary row operations, constructing the a 4 cross 5 matrix which first row alpha 1, second row alpha 2, third row alpha 3 and fourth row is alpha 4. So, if I consider like that, then I have 2 minus 2, 3, 4, minus 1, minus 1, 1, 2, 5, 2. There may be some mistake in my algebra. So, you should also cross check before accepting it, minus 1, minus 2 and 3, 1, minus 1, 2, 3 and 0. So, this is the matrix. Now, let me go for the row reduced echelon form. So, for this what I will do, I will take this basically first row is something 1, minus 1, 2, 3, 0 and then minus 1, 1, 2, 5, 2, then I will go for 2, 2, 2 minus 2, 3, 4, minus 1. Basically, I have written 4th row to the first row and your second row as it is, third row as a first row, and the first row of the original matrix goes to third row and then 0, 0, minus 1, minus 2 and 3. This is matrix please. So, let me do this one goes to again this can be written as 1 minus 1 2 3 0, just adding 0 0 4 8 2, and second one multiplying first row by 2 and subtracting to third row, I will have 0. So, basically R 3 goes to R 3 minus 2 R 1. So, that is equal to 0 minus 2 R 1 means the plus, this is also 0, minus 1 4 and then minus 6, that is minus 2 and minus 1. Okay. So, I will have like this. Then next one is 0 0, I have minus 1 and minus 2 3. So, if I go the next step, this is going to be again 1 minus 1 2 3 0, and so I can make it here. So, I can exchange the third row to this one. So, 0 0 1 2 1, and then I can have the second to the third one. So, if I do it, this is 1 0 0 4 8 2 4 8 2. Okay, so let me write down 0 0 minus 1 minus 2. So, one more step, let me go it will be 1 minus 1 2 3 0 0 0 1 2 1, and this one multiplying 4 and subtract. So, it will be 0 0 0, and this will be also 0. Yeah. So, 2 minus 4 is equal to minus 2 will come into the picture, and this will be again 0 0 0 0, and I will simply add it. So, it will basically 4. So, this means that I am getting one more step please. So, 1 minus 1 2 3 0 0 0 1 2 1, and just 1 minute please, 0 0 1, and this is also 0 0 0 0 0. Okay. So, though it is not a row reduced equivalent form, to make it a row reduced equivalent form, I have to do one more step. Let me go it. This is equal to 1, then I have minus 1, and I have to multiply 2 and subtract this ones. So, this will be 0. So, multiplying second row by 2 and subtracting from the first row. So, then 3 minus 4, that is equal to minus 1. So, this will minus 2 will come to the picture, because 0 minus 2, yeah, fine. And then I am having 0 0 1, and here I am getting 2 and 1 0 0 0 0 1 0 0 0 0 0. So, again I can make it, this is equal to simply 0. So, this is also possible. Okay. So, this implies the dimension of subspace W is 3. So, we have a basis say consisting of beta 1, beta 2 and beta 3 of W, where beta 1 I can consider as 1 minus 1 0 minus 1 0, and beta 2 as 0 0 1 2 0, and beta 3 is equal to 0, 0, 0, 0 and 1. Okay. So, I have basically basis for the subspace W. Now, question is I have to find linear functionals which will annihilate W. So, let f be a linear functional on R5. Let me define, it is defined by f of say x1, x2, x3, x4 and x5 equal to say let me consider C1 x1 plus C2 x2 plus C3 x3 plus C4 x4 plus C5 x5 type, and it annihilates W. So, this implies f of beta 1 equal to 0, f of beta 2 equal to 0, f of beta 3 must be equal to 0. So, this implies just a minute, beta 1 equal to 1 minus 1, 0 minus 1 and 0, beta 2 is equal to 0, 0, 1, 2, 0 and beta 3 is equal to 0, 0, 0, 0, 1. So, f of beta 1 will be C1 minus C2 minus C4 equal to 0. This is the first equation. F of beta 2 is equal to 0 means I will have C3 plus 2C4 equal to 0, and f of beta 3 equal to 0 means I will have your C5 equal to 0. So, now I have to solve this system to get the solution please. This implies that your C3 is equal to minus 2 C4 and C1 is equal to C2 plus C4, C3 is equal to minus C4 and C5 equal to 0. So, this means I have two free variables C2 and C4. So, put C2 equal to 1, C4 equal to 0, I will have C1 will be equal to what? C2 is equal to 1. So, C1 also equal to 1 and C3 equal to 0, C5. So, this implies I will have one set of C1, C2, C5 as C1 equal to I have taken 1, C2 equal to 1, C3 is equal to 0, C4 equal to also 0 and C5 is already 0. This is 1 and other one put C2 equal to 0 and C4 equal to 1. If I do like this, C1 equal to 1, C2 equal to 0. So, 0 and C3 is equal to minus 2. So, minus 2, C4 equal to I have put 1. So, C5 equal to 0. So, I will have this one. So, this implies that I have two linear functionals. I can say f1 which is equal to f1 is equal to x1 plus x2, f1 is equal to x1 plus x2 and f2 is equal to I can have that is x1 minus 2x3 plus x4. So, these are linear functionals which will basically annihilate your W please. Annihilate means the null space of F1 and null space of F2 contain the set W please. So, the null space of F1 and F2 include W. So, this implies that W is equal to intersection of null space of F1 and null space of F1 and null space of F2. So, intersection of two hyperspaces please. So, when the dimension of W is 3, then we see that it is basically the W is basically intersection of two hyperspaces please. So, in similar way one can also suppose subspace is given of dimension k, then we see that there exist exactly n minus k hyperspaces, which will basically intersection of the hyperspaces is your W please. Now, let me twist the problems. Now, it is like this, suppose some over the vector space V, of course finite dimensional, suppose some linear functional is given to me f1, f2, f3 like that. Now, I want to know what is that set W of vector space V which will be annihilated by this f1, f2, f3 like whatever linear function is given to me, how to do it. So, for that one can proceed like this. Now, consider a vector space V of dimension say n, consider linear functionals f1 of say x1, x2, xn. So, here I have taken here please fn suppose. Now, f1 operating on any element is 1, suppose let me define like your a11 x1 plus a12 x2 plus a1n xn. Similarly, f2 another linear functional, let me define a21 x1 plus a2n xn, and fm this is given by say a m1 x1 plus a mn xn. So, m linear functional is given to us which are defined over the vector space V. Now, we are interested to find a subspace W of V which will be annihilated by m linear functionals. How to find it please? So, here what we have to do it, first we have to find the set of linearly independent linear functionals. This has to do with the help of elementary row operations, get the corresponding, this is basically equivalent to say Ax. Now, this Ax you have to reduce to Rx, where R is a row reduced echelon form of the matrix A please. Then you will exactly come to know out of m linear functionals how many linear functionals you are getting which are linearly independent. So, suppose you get the R number of linearly independent linear functionals. Once R is obtained, then we have to find the what is the subspace of V which will be annihilated by this R number of linearly independent linear functionals. That is basically solution of Rx equal to 0. So, from that you will get a solution space W. I will get a basis for the W, and that linear combination of all the basis element will talk about the subspace W please, which will be annihilated by this f1, f2, fm linear functional please. So, you can consider as a homework, and if you have difficulties we will discuss that please. Thank you.